Okay, welcome back to this session. I'm still Simon with you for biology, and we're looking at chemicals of life and carbohydrates. We have reached so far to polysaccharides now. Polysaccharides. The words are longer, but the meaning still comes out. Saccharose, the Greek word, standing in for sugar. Sugars now, it means poly is many. So meaning that polysaccharides are carbohydrates consisting of many sugar units. In most cases, these sugar units are even repeated sugar units. So we have carbohydrates to this level that have many sugar units. So meaning very many monosaccharides make up the polysaccharides. And examples of polysaccharides that we shall take more examples, we shall center much on these two or three polysaccharides: the starch, the cellulose, and then the glycogen. For this session, let's set a match on starch, which we have heard of in plant bodies. So, if you have to describe starch, describe and say, we have think our life forms are supported by this starch here. So starch is the main storage carbohydrate, in plant bodies. Such as our local available foods, the cereals, curry, starch, the tubers, cassava tubers, potato tubers, all are storage organs of plants that store starch. So I will begin by saying starch takes up two forms. The first form is the amylose, and the second form is amylopectin. Amylose and the amylopectin. So let's look at amylose, the form of starch. Right here, say amylose now. In amylose or amylose, it is made up of alpha glucose repeated units. So we have alpha glucose repeated units in amylose. The other alpha glucose that we saw that it is cyclic and it was a pyranose ring. So very many glucose units are repeated. So meaning the glucose subunits are linked up by 1,4 glycosidic bonds. So we have 1,4 glycosidic bonds within amylose. We saw how the 1,4 glycosidic linkage is made between carbon atom number 1 of one glucose unit and another carbon atom number 4 of another glucose unit to establish that ether bond. We call it ether if it was the hypercanaming in chemistry. Then the chain is wound to form a helix. To form a helix. Each helical ring consisting of 10 subunits. 10 subunits. And also, because of presence of hydroxyl groups, the OH groups, hydrogen bonds wind the structure. So the structure is maintained with that one. So amylose form of starch is not as abundant as the other amylopectin. It is less common. So amylose is less common, and is stained blue or blue-black by iodine solution. So when iodine is added to a food substance consisting of amylose as a starch. It is stained, so and that is the basis of testing for starch. This one is test for starch. We shall revisit it and see how the procedure is performed. That's amylose. So in our next session, we shall talk more about amylopectin and understand also that form of starch.